And we're back. Don't forget to get your sweetheart something sweet for Valentine's coming up. Is that your sweetheart right here, M&M's? What about Snickers? Do they love Snickers? What about Skittles? Woo! Yeah, or maybe Hershey's. Ooh. Don't forget to get them something sweet and nice. Don't forget. Yep, don't forget to get them something nice. So where we finished off was, let's see, so 7.5. So we're on the next page now. We're on number 12. Radioactive, radioactive. All systems go. Radioactive iodine is used to determine the health of the thyroid gland. I believe it. The radioactive iodine decay is according to this equation, where T is in days. Find the half-life of this substance round to the nearest day. So your half-life is kind of the key there to this problem, right? Because you have an equation, y equals n times e to the negative 0.0856 t. But the real question is how do we set this up with half-life? What does that even mean? Well, your n is your initial population, right? So n is your initial population. That's your initial. And so you got to choose a number, like 50 or 1. And then the other side, the equal side, needs to be half of that. So if this you choose maybe n equals 50, then y over here has to equal 25. It has to be half. Has to be half, basically. So that when you divide it over, you get half. Yeah. And so I'm just going to use the number 1. I'm just going to use the number 1. Say our initial iodine, whatever, is just 1. And then I'm going to go ahead and say that y is going to be half of that. And so, like I said, it could be 50 and 25. Just when you divide it over, you should get a half. And then you have times e to the, so where t is the number of days, find the half-life of the substance round to the nearest day. And so t is the days. So yeah, so they want you to solve. So they want you to solve for t. They want you to solve for t. So here's our setup. You pause me now. Here's the setup. Sometimes that's the hardest part. So you gotta pause me. Go ahead and pause me. What do you do next? What do you do next, right? 1 is your initial. Half of that, half-life, is what we equaled. Our target, that's our target right there. Our target is going to be half. I mean, you could have chosen 50, it doesn't matter. You could have chosen like 50, for example, and this would be 25. Or this could be 4, and this would be 2. As long as when you divide it over, you get a half, right? Because that represents half-life. As long as you get half on left hand side. Does that make sense? Yeah. So we could use 50, 25, as long as you get a half on the left hand side. Cool. As long as we get half. It doesn't matter what they are. So we could choose, what would you like? Would you like, what, 4? You choose 4? What do you think? That's fine. So we'll do 4. That means this has to be, what's half of 4? 2. So now we divide it over. So as long as you get 1/2 now, that's all that matters. That's the important part. So then e to the negative 0.0856 t. And now we got to undo e. Pause me. Do you already know? Look it up. How do you do it? How do you undo e to the other side? So what's the opposite of e? ln. ln's going to get rid of e. And if you do it on one side, you have to do it on the other side. There you go. And then last but not least, this is being timesed by t. Timesed. So you're just going to divide by negative 0.0856. Divide it to the other side, divide it to the other side. And so when you plug that into your calculator, you should get something like, I think 8.1 or something. Let's take a look and see really quick there. So we're going to go, there it is. So we're going to do ln of a half divided by negative 0.0856. So we get 8.0975. So now we have t is equal to whatever this is, whatever that is. And so that is equal to 8.0975, which we're going to say it's approximately 8 days. 8 days is our answer, because nearest day. Cool. So give it a try with 13 now. Try number 13. Woo! And we're back. Something's coming up. So I got a video clip to show you. Yeah. So this is yeah. So make sure to be nice to somebody on Valentine's Day, just like Lisa Simpson. What? Was that you? Was that me?
Poor Ralph. Here you go, Ralph. You choose me? Happy Valentine's.
Happy Valentine's. Woo! Make sure you watch my next video where we see what happens after a long episode. It goes pretty funny at the end. Or not. Okay, thanks for being here. So we did number 12. And, oh yeah, this is halfway after 12. Cool. Okay, so use the following information for number 14 to 18. So find the constant k in the formula. Okay, so let's see. Well, really the problem is I want to help you with 15, but we need to find 14 in order to do 15 is the thing. So you lucked out there, 14 and 15. Maybe we'll have you do 16, 17 on your own, yeah. Okay, so find the constant k for our formula. So here's our formula, and they want you to solve for k. And so they tell us half-life is the key, as well as the t, the number of years. So those are two important features. So we have y is equal to n, e to the kt power. So k is basically the rate, and t is the time. And so k is the rate, and then e is just 2.71828, which is like an infinite number of compoundings. And then n is the initial. So n is your initial, and y is your target. And so this problem I found really weird when I first learned how to do it. And the reason why is because they didn't really give you much information to come up with the equation. But it turns out that half-life is the key. And so half-life is going to give you this guy and this guy. And so you have to choose. So you have to choose an initial and then half of that, right? So you could choose, for example, like whatever gives you a half when you divide it over. So you could choose 2 and 4. Because when you divide by 4, you get a half. And that is, so that half is a half-life. Yeah, so that half is half-life, right? Half-life. Yeah, so we could choose 2 and 4. Maybe we'll choose, I think in class for some reason, name drop, Bridger, and Porter. So I think we chose like, I don't know, maybe choose 50 and 20 because those are pretty numbers. Maybe choose 50. And what's half of 50? So half of 50 is, what's half of 50 is 25. Yeah, so why don't we choose 50 and 25? It doesn't matter what you choose. It could be 3 and 9. No, it has to be 3 and 6. So it doesn't matter what you choose. Just when you divide it over, you get half for half-life. I think when I first saw this, it was like, we'd say the target is a half, and then your initial is like 1 gram, which we could use. But who wants to use 1 gram? That's not that pretty. So let's choose something else. Maybe choose this guy, or maybe choose this guy. Either way. So just choose something that's going to give you half-life, right? Let me type that right there. So choose something, as in instead of something, we'll say choose two numbers that are going to give you a half-life. Yeah. Cool. What the? I said I want a different color. Boom. Okay, there you go. Yeah, so basically, choose two numbers. There we go. So basically choose two numbers that are going to give you a half-life, basically. Yeah, hopefully that makes sense to you. Come see me if it doesn't. And so I'll choose like maybe like 25 and 50, for example. You can choose 20 and 40, whatever you choose. Okay, so then you have your E. Next, your K, we don't know. We're solving for K. And then the time, they give us the time. And so the time they tell us is a half-life. So the time they tell us, half-life is 1620. So 1620 is our half-life. And so we're going to erase that, and we're going to plug in 1620. So 1,620 years. Okay, solve for K now. So how do you solve for K? Now that was the hard part, that was the setup. So we're going to get 50 to the other side and get our equals half. Get our half-life, divide by 50, divide by 50. And so 25 divided by 50, if you divide by 25, divide by 25, you do get a half. And so that's our ticket there. Remember, that's our half-life. That's the key. That's the half-life. So equals E to the K times 1620. And so now we want to go ahead and use magenta, and we're going to go ahead and solve now. So go left 4 decimal places. So we go 1, 2, 3, 4. And so there's our decimal, there's our decimal. And then we had a 0 there, a 0 there, a 0 there. So we have 0.000, 4, 2, 7, 8, 6. Maybe go like 8 places, I don't know. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Maybe that rounds up, we'll say 8. So maybe like 8 places. I'll try to be generous on the test, but maybe go 8 places there. So cool. So it does say do scientific notation though. So what would scientific notation look like? It's negative. So that's our answer. But it does say scientific notation. And so that would be an acceptable answer. But just for number 14, when you put it on Canvas, so I would probably put like k is equal to negative 4.279. It does say 4 decimal places, so that would actually be so 4.27. Technically, that 9, you would go one more, so it'd be 427. So 4 decimal places. So we'll do 427 and then 8, which we could say rounds up to a 9. Or maybe 4279. Either way, we'll give that to you there. Cool. So let's see here. So 4278. I mean, technically that's more than 3. Okay. So 427. Sorry, I'm just trying to decide. So 4279. Or you could also do like k equals negative 4.2787, and that 7 will round up to an 8. Anyways, okay, so it can be like, so in the scientific notation, it would be like times 10 to the negative 4 power, So really, that's what we're looking for as our answer, especially on a Canvas. Right, especially on Canvas. And maybe you can do it this way. I'll try to go on there, and maybe I'll do that one because that's the one we want to use when we're actually doing the problem. Okay, cool. So now that we found what K is, now they want you to write the equation for the decay of radium using the value K you found on number 15. You found on number 15. You found on number 14. Okay, cool. So write the equation. So we go y is equal to the initial e power, and then we have our negative 0.0004279, and then times t. And so that is basically the equation there. So if you wanted to round that to 4 decimal places, maybe it would just be 4 or 3. A little confused on that part, but that's okay. And so there's our answer there, just using that guy for that guy. Cool. So then you're going to use that formula now and to do 20 gram sample of radium sealed in a box. So you're going to find the mass. So I'll let you try that one on your own. So you're going to go ahead and find the mass now. So after 5,000 years. And so 5,000 years is your T value. And 20 grams is your initial. And so 20 grams is your initial, which is like your N value, right? So round to the nearest hundredth of a gram, find the mass of the radium after 15,000 years. And so you're going to put your 20 there, and then you have your E there, and then you have your 5,000 years. Right, you have your 5,000 years there, as well as your negative 0.00042 times times your 5,000. I don't want to fill it all in for you because you're supposed to do this on your own. But give it a try. Give it a try. And then number 17, go ahead and give it a try as well. So 17, go ahead and give it a try as well. And then we'll look at the next video. So keep on going. So when will the sample of radium be 1/4 of the original mass? So 1/4 of the original mass. So when will the sample of radium be 1/4 of its original mass? So you have basically a 1 gram. And when does it become a 4th gram? Right? Yeah. And so that's going to be times by E. And then we have the negative 0.0004279, or 4279, whatever you want to say there, times T. And then go ahead and solve for T. Woo! Okay, that was tough, but keep on going. Watch my next video. Thanks for watching. Thanks for watching. Keep on trying. You got this. Pause me, try it on your own. You got this. Pause me, try it on your own.